Okay, let's get started. I would like to welcome everyone, students, families, faculty, and guests to the 2019 Physics Department graduation ceremony. I'm Chris Carone, the chair of the Physics Department. I've been a professor in the department for nearly 22 years and the chair of the department for 2 years. I'll be the master of ceremonies for today's physics graduation ritual. Most of our graduates already know what a fantastic physics department we have at William & Mary. However, a few points are worth highlighting for our guests today. The physics department has 28 tenured or tenure-track faculty members, as well as many other adjuncts, research professors, postdoctoral researchers, and administrative staff. While we function within a unique liberal arts university, our department has a significant PhD program, brings in tens of millions in external grant support, and aims to compete with the very best PhD granting research universities in the nation. We have active research efforts in nuclear and particle physics, high energy physics, atomic, molecular, and optical physics, condensed matter physics, and plasma physics. Many of our faculty members incorporate high-performance computing in their research. A significant portion of our department runs experiments of international importance at Fermilab in Illinois and Jefferson Lab, a 20-minute drive away in Newport News, two of our nation's premier Department of Energy-funded national laboratories. Two scientists from Jefferson Lab are governor's distinguished professors in our department, a designation given only to researchers of the highest caliber and international reputation. The point that I would like to stress is that the research active environment in our department is not something only relevant to doctoral students and peripheral to our undergraduate program. It is a crucial ingredient to the value of our undergraduate degree, as many of our graduates today can attest. Each graduating senior must complete a year-long senior thesis project, and many have worked at earlier stages in their undergraduate career within research groups in the department, during the semesters for academic credit or over the summer for a stipend. Hot scientific topics that you may have read about in the popular press are not distant inspirational abstractions, but are core areas of research in our department that have involved undergraduates as active participants and meaningful collaborators. What better way to understand what cutting-edge physics research is all about than by becoming directly and meaningfully involved at the earliest possible point in your career? When diplomas are awarded a little later on, I'll read all the senior thesis titles, which I think will leave you with a good sense of how broad and deep these research opportunities are at William & Mary and how integral they are to our educational mission. Of course, most research involves close interaction between students and faculty, either in a one-on-one or a small group setting. So I'd like to take a moment to introduce and recognize the physics faculty who are attending our ceremony today. So I'll do this by research group, and if they're here, they should jump and flail around so that you could give them some love. So in high energy physics, that's my area, I'm in that group. Mark Scher, he's sitting up front because he's going to be speaking a little bit later. So Mark, we'll pause for Mark. Our zany younger colleague, Josh Ehrlich, he's way in the back. And our experimenters in high energy physics who keep us grounded in reality, Jeff Nelson. The only person who makes me not feel alone for wearing regalia. And Trisha Volley. In nuclear and hadronic physics, Kostas Orginos. In the back. And Joe Dudek. Joe told me this morning he thought I was wearing my pajamas. Bob McCune, I'm not sure if he's here. I guess he's not here. Todd Averitt. Justin Stevens. In atomic, molecular, and optical physics, Irina Novikova. Evgeny Mikhailov. Seth Aubin. And Bill Cook. And in condensed matter physics, Enrico Rossi. Gina Hotzen. Mumtaz Kazalbash. and Henry Krakauer. So our faculty were kind enough to stand in the back, but I let them know that if they would like to sit down, there's the overflow room in the other area. Or they could stand, whatever they like. Okay, so before we move on to the official graduation speaker this year, I would like to take the opportunity as department chair to give a few parting words of my own to the 2019 graduates. This is one of the perks of being department chair because I can pretty much talk about anything I want and you can't leave because we haven't given you the diplomas in the box yet. So, for a variety of reasons, I have been thinking lately about the topic of wisdom. This actually has been on my mind for quite a while. When I was a little kid, I used to visit an aunt every week who lived in New Jersey. Her name was Angela. I called her Aunt Angie. She was very interested in politics and claimed to read the New York Times every day from cover to cover. And I would more than occasionally get into debates with her over whatever political or philosophical topic was relevant at the time. In one such instance where I presented a clean, logical refutation of one of her more half-baked arguments, she responded, "Christopher," and I hated when she did that, I like going by Chris, "Christopher, you need to listen to me. I am old and I'm wise." Well, back then, I had about the same level of tact that I now have in faculty meetings. And I blurted out in the heavy New Jersey accent of my childhood, which I hope I've lost, "Aunt Angie, what if you're just old and stupid?" Okay, that did not go over well. I was part of an extended Italian-American family, so a lot of yelling ensued, but happily everything was ultimately forgotten over a plate of pasta. In any case, even at a young age, I had appreciated that the sum total of life experiences, even of a very old and crusty aunt, was not sufficient by itself to presume the spontaneous generation of wisdom. In my professional life, I've had similar experiences with more than a few physicists who, like our graduates today, had degrees from esteemed institutions, who could solve the Schrodinger equation for complicated systems, who knew the difference between entropy and enthalpy, and there'll be a quiz afterwards. Some, in ways not so overt as my old aunt, made clear their presumptions of wisdom, sometimes linked implicitly to their achievements in academia, their publication and citation counts, and their professional awards and honors. Some, like my old aunt, assumed that their seniority rendered their self-assessment beyond any reasonable dispute. Yet, experience suggests that their conclusions might be overly optimistic. As one example, I recently had to endure the emotional tirade of a faculty member in another PhD granting department, who in a spasm of self-entitled rage publicly berated me and another colleague who was very nice, it was very sad, copied to the Dean of Arts and Sciences and the provost of the entire university. Because, wait for it, I had scheduled a meeting on a Thursday rather than a Tuesday. Not so wise. And I have many other examples like that. So clearly the metrics of success in science and academia more generally are not particularly useful in predicting whether a person is wise or otherwise. So what's missing? First, I would stress that your scientific training provides you with a wonderful tool that allows you to understand objective reality with precision and to distinguish truth from falsehood. That is a necessary condition for wisdom, but far from a sufficient one. The accumulation of experiences provides a potential database from which one can learn, but by itself also falls short. What I would like to suggest to you is that the path toward wisdom requires another ingredient, introspection, the ability and willingness to study yourself and draw precise and honest conclusions. Scientific observation and deductive analysis need not be compartmentalized and only applied to the external world, but can provide an effective tool when turned inward, for unearthing subconscious motivations and unexamined biases, and for relentlessly identifying psychological blind spots, which, if left unexamined, would lead to beliefs and behaviors that are not likely to be wise. So, in summary, my simple message regarding wisdom is that you are not entitled to it. It will not simply appear as you accumulate experiences. And the amount of physics you know, the amount of research you do, the accolades you may receive in your professional life will not give it to you either. My hope is that you will be as demanding in analyzing all aspects of yourself as you would be in deconstructing any other complex physical system that you might encounter in nature. If you make that commitment, I believe you will put yourself on the path toward wisdom and towards a more fulfilling and awakened existence. So, now that I've finished channeling the Dalai Lama, I suspect that you'll find today's official speaker far more entertaining. Professor Mark Scherer, who's sitting in the corner, is one of my closest colleagues and collaborators in the department, an eminent theoretical particle physicist with a great heart and a manifest sense of humanity. Mark is also a pathological extrovert who never stops talking to people, no matter what you do to try to avoid him. It drives me crazy. One of my colleagues, who retired just to get out of a conversation with him, once exclaimed, "Mark Scherer is impossible not to find." So it's no surprise that we find him here today as our graduation speaker. As an aside, Mark told me that he was planning on conveying to you the subtleties of modern quantum theory via an interpretive dance that he planned to perform titled Why Heisenberg Makes Me Feel Uncertain. Fortunately, I talked him out of it. So, without further ado, it is my great pleasure to introduce Professor Mark Scherer.
Thank you, Chris, for that lovely introduction. I wish I had known I'd be ready to get even with him, but anyway. This is my 30th graduation ceremony in the physics department, and I have successfully avoided having to give the commencement talk for 29 years. But alas, the time has come, and it's appropriate since I think I know almost all of the students pretty well. So, okay, I'll do it. But I thought a lot about what sort of address to make. I mean, I could give a talk with all the usual cliches, follow your passion and so on and so forth. But all of you know that's not me. Okay, I just don't do that. Fortunately, I found a commencement speech bingo card that has all of these, so I'm just going to put them on the overhead and do my best to avoid those phrases. Hold it. One more time. Well,
it would not be small. Can you move the sheet up? Yeah.
okay, so you see all of those things, and I'll try not to say any of them, if you don't mind. I'm not going to give that kind of talk. I could give a talk that's mostly jokes, like when Jon Stewart gave his commencement address to the college 15 years ago and asked the students, "What advice can I give you as you make the transition from college to your parents' basement?" But most of you know that my jokes are either stolen or really bad, so I'm not going to do that. I could also copy Josh Ehrlich, who spoke like Dr. Seuss. It was quite a joke. "Welcome, dear families, students, and friends. Today you experience college's end. You also accomplished, I stand here in awe. If I took all your classes, I'd have to withdraw." That was the first of about 50 stanzas, but it's been done, and Josh is better at it than I am. So instead of giving a talk with a whole bunch of platitudes about how physics is the answer to life, the universe, and everything, which may be true, instead I'm just going to talk to the students about some of the experiences you've had in the last few years. I asked students for stories, and they provided plenty of them. So let me just go through some of the things that have happened during the 4 years. First of all, most of you started, not all, but most of you started in Physics 101 honors with Professor Griffion. And as one student related, and Professor Griffion also confirmed, awaiting our first ever college class, we all nervously found seats and waited for our professor. At 11 on the dot, Griffion entered the classroom with a Tupperware full of spaghetti, pulled the stool out from behind the desk, sat down, glanced at us, and took a bite. We looked around at each other with a mild confusion that quickly grew to total bewilderment as Griffion began to drop forkfuls of spaghetti on the floor. "Gravity," he said in his Dutch accent. your first ever science demonstration. He then mentioned how that when his daughter was 2 years old, she was sitting in a high chair and discovered the same principle many times using spaghetti as well as peas. For some reason, peas, they like to, And he says, this is the point, he said, at which many scientific careers end with a reprimand. After repeating the demonstration several times, he then mentioned that science can be very messy. So that was a first year event. The first year is kind of a hodgepodge of a whole bunch of different topics which are very loosely related. 2 weeks of this, 3 weeks of that, 2 weeks of this, and so on. The fun stuff, according to many of you, came in the course I taught, Modern Physics, where you learned about relativity and quantum mechanics, time travel, wormholes, and all the cool stuff. Unfortunately, the title of the course is a bit much. Modern Physics deals with physics between 1905 and 1930. So it's modern only for very large values of modern. And we're not going to use postmodern. That's just not a word I would use, no. One thing about that course is when you look back at it, it's kind of depressing. The whole course keeps telling you what you can't do. You can't go faster than light. You can't know certain particle properties to better the certain position, and so on. Warp drives, transporters, and all that just can't happen. It's depressing. I mean, all the science fiction we grew and knew and loved and all that, just wrong. And then the big monkey wrench is thrown in. You've always assumed that when you measure the properties of something, the properties existed before the measurement. But now you find out from Bell's inequality, they don't. Most objects do not have properties before you measure them. So you basically conclude that common sense isn't common sense. And just as you're sort of going off into Never Never Land, it's back to classical mechanics. Common sense returns. But sometimes you need some comic relief anyway, and I seem to have lost the one paper I was looking for. Oh, I see it, okay. I'm going to show you a picture which comes from the classical mechanics course. The students decided to put on some noses, and the professor, John DeLoss, walks in, sees all the students with noses, gets a nose, and puts one on himself, and then starts lecturing. Not a word was spoken the whole time. The noses actually got kind of itchy. All the students took theirs off, but DeLoss kept his on the whole time. Lecture ended, and he went off and never said anything about it. There's something funny about that. Okay. Then came junior year. Now, one thing about this class, more than any class I remember in a long time, is that they're all really bonded together. They're a very close-knit group. You all know each other pretty well. And it's really pretty amazing. The SPS and all that has just sort of been a unifying force. But the one class that students say helped bond everybody more than any other was Classical Mechanics 2 with Yevgeny Mikhailov. Most students tell me that he was one of their favorite professors. Was he? Yeah. Clap if you think he's one of your favorite professors. Yeah, really welcome. And at the end of the semester, Mikhailov said that each student could challenge him to a competition. And if they beat him, they'd get extra credit. Ooh, sounds good. So Adam challenged him to Fermi problems and won. Congratulations, Adam. Joe challenged him to kettlebell raises and lost. And Catherine challenged him to, what are V-ups? I'll have to ask you later, and beat him. Charles challenged him to Jenga and lost, and so on. If it was me, I would have challenged him to an English spelling test. English is crazy. You know? Now, in that class, and also in quantum mechanics that you took at the same time, you learned something that we try not to tell freshmen and sophomores. You learned that there are hardly any problems you can solve exactly. And you get them all, and that's it. Everything's approximations. Most things in the real world are approximations. For example, in 101, you assume that ice skaters are point particles, frisbees are perfect disks, and so on. And the standard term we use is the spherical cow approximation, where you assume that complicated objects like cows are both spherical and frictionless. And then you go from there. The rest is all computers and engineering. Now, after one of the classical mechanics classes, the students came out of the class wondering why Professor Mikhailov had been talking about cows. The spherical cow, I mean, was there approximations going on? What was it? Well, he does have a strong Russian accent, but most of us learn how to understand it within a few minutes. But finally, after talking about it, they realized he was saying chaos, which, if you know Russian, you know that the A letter is an A and the O is an O, so chaos. You know, it makes perfect sense. So blame the English language, not Yevgeny. Another thing that happens, during that same year, you have a major, finally. You're not allowed to have a major here till you're a sophomore. By then, everybody has a major, and people keep asking you, what's your major? And you say physics, and they stare at you. And they say, physics is hard, you must be really smart. Which sounds flattering for a split second before they turn and walk away. Or maybe that's just me, I don't know. This idea that physicists have to be smart, I'm not sure where it came from. Of course, it's true, but still. Maybe it came from Einstein. Fortunately, there's nobody in our department who looks like Einstein. Finally, the fourth year comes, and you think you can finally relax. Most of your mandatory classes are finished. All that's left is senior research. If you think physics is hard, senior research is harder. You can't sit up late at night with your fellow students studying and working out homework problems. There are no exams, no easy way outs. You often aren't sure how to proceed, and even worse, your advisor sometimes isn't either. Eventually, you get through it. Now, later today, in a few minutes, you and your families will hear the titles of the senior thesis project, and they'll be impressed by the breadth of the subjects covered, and in a few minutes, you'll officially have the right to call yourself a physicist, which is pretty cool. Now you're going to other things. Many of you are going to grad school. 10 years ago, there were 15 majors, and we used to talk about what each one was doing, but with 35, you can't, so it makes it easier. And the program, by the way, is somewhat outdated. There have been changes in the last few days, but so don't take it too seriously. Some will go into teaching. Some will go into industry, and will probably make more than me within a few years. You'll, of course, remember a lot of things, the Monty Python videos before quantum. Quint violating purity by shaving half his beard during a class mechanics tutorial session. I have a picture of that, but that's over there. Okay. The SPS and the physics jam sessions, and then lots of parties, lots of demos. The students are great at demos. Physics Fest, where, 200 or 300 high school kids, middle school kids come here and have demos on one day. It's really great. And this QIP conference, the Conference on Undergraduate Women in Physics, which had, I believe, 250 women in physics showing up. So you'll have a lot of good memories. I would also finally like to thank all of the mothers here on Mother's Day for sending us your kids 4 years ago. I think we treated them okay. They've done well, they're now adults, they're now scientists, and who knows what their future is going to be like. So finally, let me just say that I'm really humbled. It's a great honor to be here. This is just the beginning. Never stop learning. Follow your passion, which sounds like a stalker. Follow your dreams. Live your life, and good luck. Thank you.
Thank you, Mark. Before we proceed to the distribution of diplomas, I would like to acknowledge our student award recipients. The undergraduate awards that I will describe were actually presented earlier this year and the previous year. But I believe this is an apt moment to recognize those students one more time. So the first award is the Don Edward Harrison Jr. Award for Excellence in Physics. It's awarded to the senior with the highest demonstrated achievement in physics. The selection is made by the undergraduate committee at the end of the fall semester based on the entire academic record, the preliminary oral and written presentation of the senior research project, and 2 letters of recommendation. So the 2019 Harrison Award recipient is Jacopo Liozzi. So could you stand? Next is the Society of the Alumni Student Student Undergraduate Research Award in Physics, awarded to the seniors with the highest demonstrated achievement in physics research. The selection is made by the undergraduate committee during the spring semester on the basis of the preliminary oral and written presentations of the senior project, as well as updates by the faculty advisors. So the 2019 Alumni Research Award recipient is Robin Jenkins. Robin? The Gary Clark Memorial Scholarship Undergraduate Award is awarded annually to a rising senior with a concentration in physics who has demonstrated an outstanding aptitude for the study of physics. The selection is made by the undergraduate committee at the end of the spring semester based on the entire academic record and 2 letters of recommendation. The 2018 Clark Award recipient, Jacopo Liozzi. And the final undergraduate award is the Frank Hole Memorial Physics Award, awarded to a physics major in the spring for excellence in research performed prior to the senior year. So the 2018 Hole Award recipient, Jessica Sidnor. It's also my pleasure to present 2 graduate student awards today. The Notable Dissertation Award in the Sciences, which is given by the Graduate Studies Advisory Board to recognize exemplary achievement and significant contribution to one's discipline demonstrated by the content of the graduate student's dissertation. It is my pleasure to announce that Curtis Bartlett was selected to receive this honor for his thesis titled First Measurement of the Parity Violating in Beam Normal Single Spin Asymmetries in Elastic Electron Aluminum Scattering. Curtis's advisor is Wouter DeConnick, an experimental nuclear and hadronic physicist in our department. The award comes with a certificate and a monetary prize. Curtis is fortunately not here today. I say fortunately because he has a job somewhere else. Curtis is a postdoctoral researcher at Los Alamos National Lab, so I will share the good news with him by email later today. He does not yet know. There is one other graduate student award. This one awarded to, let's give him some. Thank you. Applause in absentia. The next award is for a graduate student who is here, Scott Barkis. And he was awarded the 2018 Roy L. Champion Award, awarded annually to a graduate student in physics who has demonstrated outstanding research achievement. So, Scott, are you here? There he is. I would like next to acknowledge the 2019 master's and doctoral degree recipients. These students are not presented diplomas at this ceremony, so most of them are not here today. However, I would like those who have indicated that they would be present to stand when I read their name so that they can receive a hearty round of applause. So among the others are listed in the graduation program. So among the 6 who are getting master's degree, Zheng Zhang, are you here? Oh, don't tell me the one person who said he was going to be here. It's not here. Okay, so PhD recipients, Scott Barkis. His advisor, Averitt, extraction and parameterization of isobaric trinucleon elastic cross sections and form factors. Andrew James Pyle. Advisor, Aubin. Scattering a Bosch-Einstein condensate off a modulated barrier. And the final one in attendance, Brandon Kyle Eskridge. Advisor, Krakauer. Local embedding and effective downfolding in the auxiliary field quantum Monte Carlo method. The other graduate students are not here, but they did interesting work, and you can read at least the titles of their theses in your program. So, last but not least, our undergraduate degree recipients. This year I've had you preceded in alphabetical order, so that should reduce the complexity of this. And so, Mark, if you could come up and help. When I call your name, I will read lots of information about you. And I will also read the title of your senior thesis so that everyone can hear it. So if you'd come over to the right of the podium. So the first is Adam Christopher Abbate. Summa cum laude. Monroe Scholar, Advisors Cook and Frey, designing and constructing Bodos, a buoyant object for autonomous travel on a surface. Congratulations. Yes, if you could all just pause for a moment, because not you could go now. Ellie is taking a picture, and your pictures will later go viral online on Facebook. And on the dark web too, but that's nothing. Okay. Jack Allmeter, PBK, Monroe Scholar, magna cum laude, BS in Physics, Advisor Cook. Analysis of the effect of DC substrate bias on the quality of sputtered lithium cobalt oxide films. Zachary Allen Baldwin, honors, William Mary Honor Fellowship, Wren Scholar, BS in Physics and Math, Advisor Stevens, exclusive neutral pion production and Compton scattering at GlueX. Anne Elizabeth Blackwell, honors Ewell Award for Outreach, BS in Physics, Advisor Auburn, Median Energy Imaging of Supernova Remnants with the Chandra X-ray Observatory. Anne Catherine Burns, honors PBK, BS in Physics, summa cum laude, advisors Armstrong and Shanahan. Pion identification through machine learning for the molar experiment at the Thomas Jefferson National Accelerator Facility. William Delaney Bushman, BS in Physics, advisor Deconic, ejectable data recorder module engineered design, a component bid for an orbital reentry flight test. Justin Michael Christian, BS in Physics, advisor Cook, automated pest detection and repulsion. Sounds like something I need in my garage. Michael Emery Crotty, BS in Physics, advisor Kazelbosch, extending the bandwidth of a cryogenic far infrared photodetector for nanospectroscopy. George Robert Denny, PBK, Monroe Scholar, BS in Physics and Geology, magna cum laude, Deconic, is the advisor. Ejectable data recorder module engineered design, a component bid for an orbital reentry flight test. Margaret Coburn Fraser, BS in Physics, advisor Auburn, photography of physics. Jacopo Liozzi, honors, PBK, Monroe Scholar, ODK, Thomas Jefferson Prize in Natural Philosophy, summa cum laude, BS in Physics and Math, advisor Rossi, chiral transport and anisotropic materials. There's so many awards, it's hard to read. Joseph Martin Guy, PBK, BS in Physics, magna cum laude, advisor Orginos, computation of changes of variables for Monte Carlo simulations with neural networks. Simon Raymond Hetzler, BS in Physics cum laude, advisors Cook and Fry, designing and constructing a BOTSOS, a buoyant object for autonomous travel on a surface. Charles McComas Jackson IV, BS in Physics, advisor Cook, fluid dynamics measurements for blade designs. Robin Madeline Jenkins, honors, BS in Physics, cum laude, advisor Novikova, measuring magnetic field gradients using electromagnetically induced transparency in rubidium vapor. Austin Thomas Kolaski, honors, Monroe Scholar, BS in Physics, advisor, Mikhailov, reducing quantum uncertainty via spatial optimization. Benjamin Seth Lazarus, PBK, BS in Interdisciplinary Studies, magna cum laude, advisor Schneip, controlled biomaterial utilizing diatom nanostructure. Alexander Michel, PBK, BS in Physics and Math, advisor Scher, Lorentz violating Z bosons in elastic and inelastic electron-proton scattering. John Harrison Mitchell, honors, BS in Physics and Math, advisor Ehrlich, exploring stochastic quantum mechanics and emergent gravity. Congratulations. Quinton John Olson, Monroe Scholar, BS in Physics, summa cum laude, advisor Aubin, thermal, mechanical, and electrical engineering of an external cavity diode laser. Gaetan Poirier, BS in Physics, advisor Ehrlich, massive gravity, perturbative expansion about the standard cosmological solutions of general relativity and its effects on early and late-time evolution of the universe. Alicia Ann Remington, BS in Physics, advisor Stevens, analysis of the photoproduction of charged kaons at GluX in the reaction gamma proton goes to K plus K minus pi 0 proton. Mary Elizabeth Robinson, honors, BS in Physics and Math, cum laude, advisor Armstrong, machine learning and electron track reconstruction for the molar experiment. Aurora Bianca Santangelo, BS in Physics, cum laude, advisor Deconic, ejectable data recorder, module engineering design, a component bid for an orbital reentry flight test. William Schubert, BS in Physics, cum laude, advisor Cook, electrodeposition of lithium cobalt oxide onto various metals. Ryan Sinclair Sell, BS in Physics, advisor Cotan, investigating side chain dynamics of host defense peptide Poseidon 1 using H2 solid state NMR. Connor Simpson, honors, PBK, BS in Physics, summa cum laude, advisor Valhalla, a qubit algorithm for simulating the nonlinear Schrodinger equation. Charles Edward Solon, honors, BS in Physics, magna cum laude, advisor Cook, construction of an auger microscope. Cameron Delaney Sullivan, BS in Physics, advisor Aubin, simulation and construction of AC Zeeman microwave traps. Samuel McCrae Swanland, BS in Physics, Advisor Averd, Uncertainty in kappa 0 for potassium and helium-3 polarimetry. Jessica Lee Sidnor, Honors, PBK, BS in Physics and Math, summa cum laude, Advisor Nelson, Minerva High Energy Test Beam Calibration. Andrew William Warwick, BS in Physics, magna cum laude, Advisor Cook, Automated Pest Detection and Repulsion. Samuel Walter Wiles, BS in Physics, Advisor Share, Energy Loss for an Electric Dipole in a Medium. Rollin Nathaniel Woodford, BS in Physics, Advisor DeConic, Ejectable Data Recorder Module Engineered to Design a Component Bid for an Orbital Reentry Flight Test. If you didn't figure out, some of these are group projects, so that's why more than one student has the same title. And we are down to the very last. Jared Arthur Worden, BS in Physics and Math, Advisors Armstrong and DeConic, Muller Beam Dump Simulations. So I think we have made it through, everyone. It is my understanding that tradition requires that you all flip your tassel from the right side to the left side of your mortarboards, which, by the way, also turns off the tracking devices we implanted in you when you declared your major. Congratulations to all the graduates. This concludes the Physics Department graduation ceremony. I wish you all the best of success in your post-William and Mary era. Before everyone else gets up to leave, I would like all the graduates to exit first and regroup in the main lobby so that Ellie can take a group photo. So if you would all rise and start heading out to the lobby, Ellie will organize and take a picture. As they make their way to the lobby, let's give a round of applause to all the new physics graduates.